All right, here we are looking at a few absolute value inequalities in two variables. We are going to graph these very similar to how we graphed our linear inequalities back here in example 2. So notice if we do a quick review, we graphed the boundary lines associated with the inequalities, and then we used a test point to determine where we should shade, okay? So we're going to do the same thing here. We know that absolute value equations in two variables, that they graph to be v's, right? So we're going to graph the v first, and then we're going to use a test point to decide where we should shade in relationship to that v, okay? So if y is greater than the absolute value of x minus 1, I'm going to start by identifying the vertex of the v. Okay, the vertex would be the point 1, 0. Okay, we'll plot that. And then I'm noticing that the a value of this particular, the associated function is 1, which tells me a couple things. It tells me that the v opens up, and it tells me that as I move up 1 unit from that initial vertex point, I can go right 1 and I can go left 1 to get more points. So from my vertex, up 1, right 1, keep on doing it. Or you can go up 1, left 1 from the vertex, keep on doing it. Okay. Now when I connect all of these points together, I'm going to use a dashed line because these points are not actually part of the solution set. Okay. And now I pick a test point to determine where to shade for my solution, okay? So once again, I can use the origin as my test point. If I plug 0 in for y, as well as in for x, I'm going to end up with 0 is greater than the absolute value of -1, which becomes 0 is greater than 1. That's false. So that's telling me that the origin is not part of the solution set. Well, the origin's down here below the V. So this is telling me I'll actually need to shade above or inside the V, however you want to describe it. So right here's my solution set. Any point in there will give me a true statement in the inequality. All right. Second example, we're going to approach very similarly. Start by identifying that vertex in -1, -3. Plot it. My a value is 2, so from the vertex I'm going to go up 2, I'm going to go right 1, keep on doing it. Or from the vertex go up 2, left 1 for the other side of the V. And this time the V can be solid, which means the points of the V itself are part of the solution set. Okay. Test point of the origin again. So 0 is greater than or equal to 2 times the absolute value of 0 plus 1 subtracted by 3, or 0 is greater than or equal to 2 minus 3. 0 is greater than or equal to -1. That's a true statement. Okay, so you can see the origin, it's above the V or inside the V. It is supposed to be part of my solution set, so I should be shading once again inside the V here. Okay, moving on. All right, in this final example, I have another absolute value inequality, but what we want to notice is that it's only in one variable, okay? It's only in one variable. So I'm actually going to have to do a little bit of work on this first before I can try to do anything with a graph for the solution set, all right? I have to solve this inequality like I did back in our first chapter, okay? And we have to recall that an absolute value inequality in one variable is actually a compound inequality, okay? So recall, this can be broken up into an and compound inequality. You can make this y minus 2 is less than 3 for your first case, and the negative of y minus 2 is also less than 3. Okay? Solving each half, I'll get y is less than 5, and then I'll divide by a negative here. So y minus 2 is now greater than negative 3. Notice I flipped the inequality symbol. Y is less than 5, and y is greater than negative 1. So technically, since this is in one variable, we could graph it on the number line rather than in the coordinate plane. So on the number line, it simply looks something like this, right? If y is less than 5, go this direction, and y is greater than negative 1, we go in this direction. And what we're doing based on the word and is we're looking for the overlap of those two lines, right? And that would be in the middle here between negative 1 and 5. So here's our final solution, right? All numbers between negative 1 and 5. Okay. Well, how do I graph this if I want to do it in the coordinate plane, thinking of it in 2 dimensions? Well, the boundary lines would be y equals 5 and y equals negative 1, which are both horizontal lines. So we'll do a horizontal line up here that's dashed. And we'll do another horizontal line down here that's also dashed. Okay. And then we want to be any point whose y coordinate is between 5 and negative 1. Okay. So that would be all of the points in between these two lines. Doesn't matter, notice it doesn't matter what the x value is because there is no x variable in this inequality. We're only focusing on the y variables. As long as y is between 5 and negative 1, you are a solution. Okay. Notice had the inequality instead been x minus 2, the absolute value of that less than 3, instead of horizontal lines, I would have graphed vertical lines at x equals 5 and x equals negative 1. But other than that, everything else about this process would be the same. Okay? All right, that's it for this video.